Hello.
Hi.
Okay.
How's it going, Michael? How's your break?
Can you hear me all right? Or
Yeah, I can.
okay.
Is my mic not working?
No, it does. It does.
Yeah, it does. I was just not sure if mine's working.
Eventually, Derek.
So
Happy New Year, folks.
Yeah.
Happy New Year.
Happy New Year. Hi, Matt.
Hi.
So, GraphQLConf's coming to your hometown.
I know. Exciting. Although I won't get to travel this time.
Yeah.
So now it's the after party is at Martin's place.
Well, I'm not sure if that'll fit. It's already pretty
That'll do.
Yeah.
We bring drinks. No, but it's pretty expensive. I already saw the hotel prices.
Oh yeah, hotels are pretty expensive.
Surprisingly expensive in this week for whatever reason. Because now, if you book now I checked the price of a hotel now, you pay like 180 euros or so.
No, it's now 300.
Yeah. But no, if you book it now for the next couple of weeks, it's pretty.
Oh yeah, it's right.
But if you go and book it in September, it's like double the price. I didn't know.
Yeah, pretty sure it's because of GraphQLConf.
Yeah, it must
Yeah.
be for these 300 people that will come, Well, at least you guys get an excuse to come to Europe. So
Are you
I'm
joining?
really
Derek,
looking
or?
forward to that.
Yeah, for you then it's a multiple week vacation because you can then go to France and Germany, eat Swiss cheese. Okay. Oh,
Hey
there's
guys,
Kat.
nice
Hi.
to meet you all.
Nice to meet you, Peggy.
Folks, Happy New Year.
Thank you. Same to you.
Yeah.
It looks like we're missing one person, but I haven't figured out who it is yet.
Who's
no?
joining from your team as well, Sergey?
Yes.
Yeah,
David.
David from Ungraph. I already pinged him.
Yeah, it doesn't matter.
Join,
It's
so.
just okay.
We'll give him another minute to join, otherwise we'll just kick on. Looking forward to seeing you all in Amsterdam.
Yeah.
Yeah. Have you seen the hotel prices, Benji?
I just heard you discussing it, so no, I'm gonna not look.
It's worse. It's worse than in San Francisco.
Well, no. I mean, at least one thing is that the GraphQLConf probably is not at the building where the room price is absolutely insane. I mean, we paid half the price with speaker discount for the room that we stayed in another hotel in San Francisco.
Is anything going on September in September 25, Amsterdam?
Always something happening in Amsterdam, dude.
Amazing.
All right, let's get started. Hello, everyone. Welcome to the first primary composite schemas working group of 2025. Thank you all for being here. By being here, we have agreed to the specification membership agreement, the participation guidelines, the contribution guide, and the code of conduct, links to all of which can be found in the agenda file. We'll start off with a quick introduction of the various attendees. We'll go in the order that they are in the agenda document. So we'll start with me. Hello, everyone. I'm Benji.
Hi everyone, I'm Michael from Jelly Cream.
Hey, Shane from Apollo.
Martin from Apollo.
Yeah. Hi everyone, I'm Sergey from Modern Graph.
David from Undergraph. Hello.
Pascal from Chili Cream.
Camille from the Guild.
Hey, Jeff from Apollo here.
I'm Derek from Apollo.
Thank you very much, everyone. It would be really helpful if people can help take notes during this meeting. I will be trying to take some notes, but it would be especially helpful if other people can join in as well. Are there any volunteers?
Yep, both Jeff and I can help.
Fantastic, thank you.
I posted the link in the
Thank you,
chat.
Michael. All right, just having a look through the agenda. We will look at previous action items. There isn't normally any. We will review the spec process, the progress, sorry, validate the spec structure, and talk about satisfiability. Is there anything else that people would like to make sure is covered today? We will leave the automated note-taking discussion for asynchronous. Okay, fantastic. Thanks, everyone. In which case, let's have a quick look and see if there are any action items. There are no action items. That is now complete. So we'll hand over to Michael for a review of the spec progress.
Yeah, there's actually one action item, but
it's not marked ready for review.
exactly. It's still in progress. Okay, so we have done a lot of work on the specification text. Let me quickly share over the last couple of weeks, and it, especially in the areas where we discussed, like validation and the directives, is now a ton of spec text. Yeah. So one thing I have done is also link the specification text here, just for convenience.
Good. I was
Easy.
searching the link just now.
Yeah. Yeah, it's also linked here. Benji added a link here to Netlify. I added here the actual spec link back. And there are a couple of other things, by the way, in regards to pull requests. Benji actually integrated Netlify now, or the Netlify, whatever. That means if you're doing a pull request, you get the spec change already rendered. So you get a temporary link and you can see how the spec is rendered for this pull request, which is cool, and also how the core spec does it. Okay, wait. Just
Michael, the GraphQL.github.io, does that auto deploy now?
Yes.
When you merge domain? Yeah, perfect.
Yes.
That's the only reason I linked to the Netlify was because I wasn't sure if it did or not.
Yeah, and you can see that here. Like 6 hours ago was the last published.
Perfect.
So every time you have a merge on main, we publish that to the GraphQL.github.io. And that is now much easier to if you just want to read the specification, it's much easier now. Okay, so the specification text, we added a lot of things, a lot more text. It's not yet fully polished, but there's now a lot more spec text about rules, about directives, and just in the process, while we were working with 4 people on that over the Christmas holidays, we also, if we find something in the spec, even if it's a small thing, we do an issue. And so if any of you guys review or find something, just open an issue, even if it's a small thing. just because otherwise we lose track of where to change something or where things are open. And there are, especially with the validation algorithms, like there are still a lot of things that need to be amended or maybe missing or whatever. Okay, so for the directives, we have now for each directive examples, description what they do. I especially provide now things for shareable here, where you have cases with the example for the various things we discussed. I also integrated it now with shareable on top of the object types, just like we have in Apollo. We were discussing, if you remember right, if we in the core specification just prescribe it on the field and allow people to put it on the type in their implementation. But I think if that is anyway the case, then we should just take it over like it is in Apollo Federation, except if there are objections to that. We also have for provides now examples how it works in here. External is now also complete. The thing about external, so at the beginning I thought external is just useful when we talk about requirements, provides, not requirements, provides. But it turns out it could also be useful in a key case, right? When you have keys, but you don't, like in this case, you have two lookup fields, but the key is only available basically if you pass it in. So if you get the product through this lookup, you would have SKU, but you wouldn't have UPC, right? Pascal?
Yeah, just shortly as a heads up for next week's discussion, there will be a point where we again talk about keys in lookups, because during the implementation we saw this use case exactly that Michael shows now, and the point was basically you now with the double bookkeeping that we decided to do, you have to define external and an implicit provides just because if you wouldn't have to declare that, then it would be enough to just declare name as string. So it's just one thing that we noticed while implementing it. It's that because we do double bookkeeping and we specify the key specifically, in a case where you have two lookups with two completely different keys, you would have to define fields which are external, which you will never use, you know. But that's just one thing. I will write this down and then put it into the next work group. Sorry.
Yeah, I was just going to add, I think that this is fine. Apollo Federation actually allows you, it has an implicit, if it's marked, if something is a key, the field is like considered external automatically, but adding the directive doesn't break it actually. Like you can add external.
Is it considered external or shareable implicitly?
It's shareable.
Well,
Shareable.
in two, it's external because
Shareable.
nothing is shareable.
But it's considered, why is it considered external? Because it could also be non-external in this case,
Yeah.
right?
It shouldn't be external.
Because if I don't mark it as external, I would expect if I get the product by SKU that I also can get UPC.
Yes. But it should be like it shouldn't be external in my opinion because the field actually exists in the subgraph. So
But only through one path.
Yeah.
I don't know. Does it really? I mean, it's a regular endpoint, no? To look up is like another root field. It could be like product by SKU, UPC, or just product, right? Or like
Yeah,
products.
we talked about this a bit. And the thing is, think about this. If these both have their own lookup tables, because an optimized call, you have your own lookup tables for it. In this table, where you look up this thing, you only have UPC. You don't know anything about SKU. In the other case, you just have SKU, but you don't have UPC.
But that's like you assume that's the implementation. But from my understanding is that like whichever key you provide, I will give you all the fields I have.
It's
and that's-
definitely an exceptional situation, and it's not something that's currently supported, because currently when you define multiple keys, we do assume that all key fields are available on an object that's returned.
Okay. Then we can cross this case completely out if that is not needed. This was like one case we discovered.
As far as I know, Shane.
I was calling
for-
this might warrant an issue discussion, or if we want to move it to the second part of the meeting. But I was calling out specifically that I think, regardless of what we do, Apollo Federation in its current state would support both methods, or would support us adding directive, even if like we in our current spec we don't specify that you must do it.
So the external on keys, that's a Federation 1 artifact. That's how it was actually done in the past. And that was actually, it's ignored in Federation 2. So has no effect per se. And as Camille said, is basically the assumption is if you look it up by SKU, if you look at a database, you would have both SKU and UPC when you actually resolve that entity. That's the assumption. And sorry, David, I jumped in before you. Go ahead.
I actually had a private discussion with Camille, maybe 3 or 4 weeks ago, because my understanding of external is that it actually covers 3 separate things. You have not basically an artifact, like you said, of Federation 1, where it doesn't really do anything. Second one, where it means really it is external, like it is not resolved in that graph. And then there's a third instance, which basically means it's conditionally resolved in that graph. And I actually identify this as 3 separate cases. And I'm not sure it's true that in V2 it's ignored. In V2, external without an extend, when I say extend as in an extension, it would actually be interpreted as not being able to be resolved in that graph. The same for in Federation V1. If it's not an extension, it means it's not resolvable in that graph.
Yeah, so we probably need to define the behavior here. So external is described here. Can you scroll up quickly? So yeah, so let's create an issue and then people can comment on it, because it's important that we describe its behavior correctly, because at the moment, I think it's not clear what it should do.
That's why I also brought it up to our discussion. In any of these cases, I would say I'm just going quickly over them. There are a couple of discussion points, and you can see also in the issues, like here, there are lots of discussion points that we already raised around these things, right? What I would recommend, I'm quickly going over these, and then you read these things asynchronously, this chapter, source schema, and then open issues with questions. So everybody, because then we can pick them up and have more structured discussions on them next week. Because there's tons of new spec text, and otherwise we get stuck on these. But these are one of the issue discussions that we have, and yeah, we need to define it more. I can see that from the discussion. Okay, so basically all the directives have now the spec text and also examples. There's one thing we also have open regarding source schemas, is that a source schema must have a unique name in the merging process. The question is, do we want to set that in the document as a directive? That is, at the moment, you would kind of need to track that somewhere else. Is also just a discussion point, right?
Yeah.
We could,
and the reason we want the name specifically is for override here.
Is that the main reason?
Yeah. It came up with override because we are referring to the schema here, and then we are referring to the schema also in the merge process. But where does the schema name come from? We don't describe that. It's also just we should discuss it. Should it be as metadata as well in here? Then we would need to introduce a directive for the schema that has such metadata, and then we would know where all these names come from. Doesn't have to be. We could also say you have to solve that in your implementation, and it comes from wherever you want to. In that case, we just would state that the schema name needs to be unique and comes from whatever. Also a discussion point we can open for next week. But David?
Would you prefer my thoughts on? I have a couple of thoughts on this, but I can also add it to the issue rather than take up the discussion time.
Yes, yes, because like I want to use today's meeting mainly to have an overview over things, and then we should have a couple of discussions on these, and then I would say next week we pick up detailed discussions on various topics.
Okay.
Does that sound good?
I have a little bit of a meta question about this. Looking at the override directive, it says override from string, right?
Yeah.
And you've said that the string there represents the name of the schema.
Yes.
My question is, should we be using more precise scalars for some of these things? Like, we could even just use ID here, for example, but maybe like a schema name scalar might be better.
That would be what we could do. We have scalars for things like that. Like if you look at the things we worked a bit more on, like is, for instance, we have a specific scalar here for field selection map, which represents certain syntax. For this directive, I basically did a copy from the Apollo spec. This is the original, like this is one of the original Apollo directives that I just first took over, and now we are specifying it down, and it could very well change to schema name scalar if we define the schema metadata in the document. But this is exactly the discussion. We have to do that. Go ahead.
Okay.
So I would personally vote to actually keep the custom scalars whenever there's like a specific syntax requirement behind them. So you have like a field selection map on this, like how you're mapping stuff. Yeah, there's like some implied logic there, right? Same thing for the keys when you specify the selections there. For overrides, it's mostly just a string per se. So there's nothing specific there. And this is actually a string that's coming from it's going to be only available in like a supergraph. So your one subgraph is not going to be defining all the other subgraph names anywhere. So it shouldn't be enum or whatever, right? Supergraph, sure, enum makes sense. Here, I'm not sure if you get any value of custom scalar.
The question is if it has, so if it's any string, true. If the string has any restraints, like for instance, if it does it have the restraints of a GraphQL type name, then it should have a scalar. But these are also discussions when we let's discuss that in more detail when we go into the schema discussion, schema metadata discussion. If that's fine, because the next thing is a lot. Okay, so this is what we have here. Go over it, make your notes, put them in an issue, and then we pick up detailed discussions on each of them over the next couple of meetings. So validation is another topic. We have actually two topics here. A bit is about structure, and the other bit is about really the validation rules. So there are now a lot. Like Pascal really worked a lot on the validation rules, and they are not fully complete yet, but we have now, I think that's, what do you think, Pascal? 70% of the validations rules needed?
So we have, let's say it this way, we have all the rules that we now know of. So there will be rules which we still miss because no one has thought about it in general, or B, other implementations like Federation do not use that, so we didn't have this use case. We don't have like, I spend a lot of time looking at the error codes of Federation, and I could use a lot of your test cases that you provided, Camille. This was really helpful to understand what they actually do. And based on this, we've defined to the rules that we already had, these additional rules that apply. So there is a lot of like root query types used as, for example, one of the errors, which is obvious, which is obvious, but which we didn't like. We had to have a look at the error codes to see that this is probably what it is about. Anyway, so about this, when you review this, please, you don't have to like in detail go through everything, but if you could just give it at least, you can of course go through everything in detail, more than happy about this. But if not, if you don't have the time, please just skim through, because as some of the error codes which are from which we took one to one from the Federation error codes page and from the test cases that Kamal provided, just have names which do not make sense or which could be better. We've already fixed a few which we thought now have a better name. So just go through it. We don't at the moment is the best time to rename something. If you always hated the name, speak up now. So that's something that we can do now. It's just going to get much more costly when we do it later.
Yes, and also here we found already a couple of errors. So basically Pascal wrote them, and then Glenn, another from the team, implemented them to see if they make sense. We also have a parser implementation for the field selections map syntax, and we found also tons of errors in here that are already fixed in a pull request. But it would be good if also everybody else goes through and looks at the algorithms.
Maybe quick note, additionally to validation, we also have the merge algorithms. These merge algorithms do not make any mention about a supergraph or whatever, as we have discussed. At the moment in this validation step, in this schema composition, the rules, as also described, by the way, on the roots, are like this. Pre-merge validate source schema has access to exactly one source schema. Pre-merge validation has access to all source schemas, but not the compose one. The idea of pre-merge validation, as the name suggests, is to validate that we can merge. Then we merge, and the post-merge validation is basically just the composed graph plus the context of all of the source schemas. So we don't say which metadata you have to preserve. We say that we have rules that say, for example, a field which has a default value in the composite graph also needs to have this field let's put it the other way around. If you have a default value, this default value cannot be inaccessible as the perfect example, right? So do you have the context of both the compose graph and all the source schemas? So what the merge does.
Can I interrupt, Pascal?
Yeah.
Can you take over the screen sharing? Because I have to drop off.
Okay. 1 second.
Sorry for that.
Nice. So when we look at this, then you see the merge rules. The only thing that they do is they describe, let's take the input, for example, how the input is merged, how we merge different source schemas into one single definition. And it explains what we do with inaccessible type, how we combine descriptions. At the moment, we just take the first non-null description, how we merge fields, and so on. So the algorithms do not care about schema metadata in the supergraph. They only care about how we change the shape based on the directives that we have. So you will find stuff when you, for example, look at merged object type, is that we just drop all the fields which have a requirement, because the requirement we don't care in the composite graph. So that's one example of this. And as soon as you drop an argument because it has a require on it, then all the other arguments have also to be dropped. So that's these merge rules. Exactly. Okay, so from the rest of the specification, there's not much new. So I think that's what we've done in the last couple of weeks, and we can go to the agenda topics. Does someone have them attend?
Sorry, Pascal. I was just looking over that text that you had there, and I got a little bit confused. Maybe I'm wrong, but you have on step 9, you've got let arguments be an empty set, and then on 11a, you've got let arguments be the set of arguments. Is that two different arguments? Variables.
Oh yeah, it is. Yeah, you see, that's exactly what we have to find. Yeah, let me make a note. That's wrong. Yep, that's one of the mistakes that we have to find. That's definitely a mistake. To open the agenda to know what we're going to talk about.
All right. Well, maybe it was editing file. We can move on to the 2 topics.
Yeah. Okay. So what was the first topic in the agenda?
The validation spec structure, I think we just had covered, right?
So we've discussed, I mean, I think we're still in the
6 and 7 and 8
review spec process. Yes. And then let me move that away. Validation spec structure. Yeah, so that's a good one. It's about the validation rules. And we have initially discussed that we want to have 4 sections. I know that in the schema composition. And I know that Benji already said that we should probably remove the nesting here so that we don't have so deeply nested structures. But at the moment, a lot of the rules that we have are set as pre-merge validation rules. But we have actually this validate source schema step. And a lot of these rules can actually be validated in this step. And before we now take these rules, rewrite them, and put them into the validate source schema, we wanted to discuss if we want to do this, or if we want to keep the structure as is, or even remove validate source schema. To give you a bit of context here, there is, for example, something like, let's take root query type used. This algorithm basically goes over all schemas for each schema and verifies that there is no query type which is not called root. It's not called query. And this could very well just do it for one schema instead of for each schemas. And that means that it wouldn't belong in here. That actually means that it's probably a validate source schema validation rule. And there's a ton in here that just validate one schema in isolation. And when I analyzed the rules and looked at it, I realized that when we move everything in here that only validates a single schema, then we really have just the rules in pre-merge validation, which are to verify that we can merge. For example, type mismatch, argument mismatch, and all these kind of things. So my personal opinion is we either remove validate source schema and only have 3 steps, pre-merge, merge, and post-merge, or we move everything in here into validate source schema, which makes the algorithms a tiny bit more simple, and also puts more emphasis on the pre-merge validation rule, that they are actually there to verify that we can merge, because then it will only be like 10 rules instead of 40. So that's a bit the question is, what are your opinions on this?
That makes a lot of sense to me. I think it's a lot clearer if we separate out the rules that don't need access to other schemas. There might even be might even help us in tooling, for instance. Like we might be able to validate these schemas in isolation.
Yeah, I think that's actually it's a good call out. So the validates source schemas, that those validations could be done in the library, right? So whatever is the GraphQL Federation library for a given language could actually do those in the given subgraph, right?
Yeah, I mean, it's a step of the composition. So again, the spec doesn't talk about where these steps must happen, but on each composition you want to run this. So yeah, but okay, let's put it the other way around. Does anyone think that this doesn't make sense or has any concerns? I take no answer.
Is there any particular reason why 3.2.1 can't just be 3.2 and then 3.2.2? Yeah, like just bump them up a level is what I'm thinking.
We've discussed this already, Benji, in last year, I believe, last session last year, and we just haven't restructured it, but it's fine. I mean, we took your you've already mentioned this, and we took your advice. We just haven't moved it up yet.
Okay, cool. Yeah,
it's completely fine. We can move this up. Then we have a more flat structure. We checked with the official the graphical specification, and there you also have a nesting of 4 levels. But this merge source schema step can also just be non-existent. That's fine as well. So
yeah, I think the reason for why we kept those separate was, but logically that is like the merging step, right? So you have validate the source schema, then you do the merging, and after merging you validate satisfiability, right? So those are like 3 kind of like separate, logically separate steps, but could be flattened out. That's fine.
So one reason why we kept this is exactly like you said, Derek. It's a bit easier to describe what merge does, and then what pre-merge does, and then what the actual merge step does, and then what the post-merge validation does. So this is like the description, which can be a bit longer at some point, about what these 3 sections do. It's basically we merge the schemas together. But I don't really have a strong opinion on if we should nest them or not.
I think that what you're actually saying is actually really significant, which is that these are really 3 separate processes. Checking an individual source schema is like 1 step. And then later there's checking all of the source schemas together. And then later there is checking the resultant schema. I don't see a reason that those shouldn't be 3 separate chapters, except that maybe 2 of them might be quite short, is what I'm gathering from you. But honestly, I think it would make sense to make them 3 separate chapters.
I think it's still clearer to group them under a schema composition step, because composition is different from like source schema authoring and execution. I mean, those are the sort of the top level stages we're describing.
So you mean that we don't move them up to the root, but we move them up to 3.3, 3.4, 3.5? Or keep it the structure as is?
I was responding to Benji's suggestion that we basically remove the schema composition group.
I think it's more about removing the merge source schema group.
No, I think what Benji was just suggesting was a step further, was removing schema composition as a group, right? Or did I misunderstand?
No, that is what I was suggesting, is essentially, yeah, hoisting up 3.1, 3.2, and 3.3 to be their own chapters, which may require a little bit of reworking. But the main, if you look at the main GraphQL spec, there are, what, 7 chapters? Yeah, 7 chapters. And each one focuses on like one thing, one sort of fairly tight thing. So like language talks about the actual like grammar and stuff. The type system talks about all the different types that we have, which is again one thing. Introspection, just the introspection schema. Validation talks about this one step of validation. If we were to have a separate step of validation, which is something that we've considered, or like people who implement GraphQL often use, like a runtime validation that has access to the variable values. For example, if you want to enforce things like pagination, you need to know what the values of variables are. If we were to introduce something like that into the main GraphQL spec, that would not go in the validation chapter, chapter 5. That would be a new chapter, chapter 5a, that talks about this second like validation phase that happens just before executing a GraphQL request. At least that's my opinion, because it's a separate like phase. And I think that is true of what you are talking about in the schema composition chapter. Is you've got these separate phases that execute as a with like different inputs, I guess. I can see the value in having it as one chapter as well. I'm just wondering whether exploring putting them as separate chapters might help clarify why they make sense as having separate inputs, for example, like just looking at one schema versus looking at all the schemas versus looking at the final schema, that kind of thing. It may help to clarify that. I don't know. It's just a off the cuff thought.
I don't necessarily think so, because I still think we can use Pascal. If you just go to the root of 3, like 3 with no nesting, right? So at chapter, or just click on it and go to the spec text of 3. Like click on that little 3 there. Yeah. So here at this section, at the intro to chapter 3, we can put a lot more text, but all the steps we do are sequential, right? They need to happen as like you validate the schema, and then you pass that validated schema to the pre-merge composition. You take that pre-merge composition, you pass it to, and you actually do the merging. So all these are just steps, and I think it makes sense if we just do the general chapter 3's composition, and then we have 4, 5 steps, whatever that is. 3.1 is validate your schema. 3.2 is pre-merge your schema. 3.3 is merge your schema. 3.4 is post-merge your schema. Like, right, just nice and flat, and are all steps of schema composition. Because you do need to do them in that order, right? Like they're not things that are separate and unrelated. They're all very much, you need to do these things one after the other.
Yeah, I think that actually makes quite a lot of sense. I think it maps better to actually the execution phase of the GraphQL spec, like it is talking about executing this series of things in this particular way, one introducing each concept one after the other kind of thing. So yeah, I think I had slightly misunderstood exactly what it is that you're doing here, and since it is a single process that feeds the output of like effectively the previous bit into the next bit, yeah, making it one chapter does make sense.
Okay, we can do a vote on this in the next primary next month. I think what we have to do is we have to quickly, it's basically three approaches that we have with benefits and drawbacks. One is we put them as roots. The other one is we have validate, merge, and validate satisfiability as is with these subchapters here. Or we move the pre-merge validation, merge, and post-merge validation one level up, so that we have 3.3, 3.4, 3.5. I've just posted an issue into the chat in Zoom, and we can have a look at this, and then we can make a vote, and then we can see, because it's one thing which I don't want to do is to just move it up to then move it down again, because moving it up means I have to create a new, well, if we want to do it clean, I have to create new files for all of the different steps. So I would like to explore these ideas and then see where we land on. So let's create an issue, and then we can take a vote what we want to do next.
And regardless of the structure, do we all agree that rules that are currently under pre-merge, but that only apply to a single schema, should be moved to validate source schemas? Or do we need to discuss that further as well?
Is there any
I'm
reason that you wouldn't do that?
Yeah, exactly. Does anyone has concerns about this? If not, we'll do it, because
if you can do it in isolation without looking at the other subgraphs, totally makes sense to move it to just validate.
I've already created issue 129, which said that I will do this. So then I will not close this issue, and we'll clean this up. Okay. So that's about composition, about validation. Now, there's one step at the end of validation, which is called satisfiability. And what we have to do is we have to at least get a common understanding of what we want to put in here and how deep we want to specify satisfiability. Essentially, from what I heard from the discussions, satisfiability is, so what satisfiability does is it verifies that all executable queries are really executable on the composed graph. So what you have to do or what implementations do, like for example, Polar Federation, is store metadata on their supergraph, and validation step go through this supergraph and verify that all possible queries work. And we've had this, it's quite a complicated process. And we have different ways of implementing, of specifying it. The simplest way is we just explain it with text without any algorithm, but it's also the way which is the least accurate one. Another way would be we put more effort in it and be more accurate and have an algorithm which is more general. And the third way is we would have an actual implementation algorithm, how it's done. And like in the graphical specification, we don't really have to worry about performance of the algorithms too much, because you don't have to implement them one-to-one to be compliant with the specification, as long as the outcome is the same. And I think if we just forget all of the performance improvements that have been done to the satisfiability algorithm, we might be able to actually specify an algorithm that could be possible. And it could be possible to specify an algorithm that does the satisfiability. So does anyone has opinions on which approach we have to choose or which we should explore? Yes, David.
Perhaps I'm being naive, but unless you're, I think everyone who's creating a composite schema needs to understand that everything needs to be satisfied, but is it important for them to understand in an in-depth algorithmic way how that is determined possible? Because unless you're writing your own composition library, you're never going to actually implement that algorithm yourself. You just need to understand kind of some examples of why something might not be satisfied, as opposed to like an in-depth algorithmic approach. That's my
Well,
kind
it's
The purpose of the spec is to help people implement it.
exactly. So the spec is there for people to implement their own composition libraries. So it's not a documentation about how the composite schema works. That's also why we have algorithms for merge and not only examples. It's how it's done. It's the same way, imagine the graphical specification would just write, and then you return the data in the same shape that you requested it. That would also not really work, right? With a few examples. So I personally, my opinion is that we probably have at least to try to put it in an algorithmic way so that it really becomes clear what satisfiability means. Because depending who you talk to, satisfiability is like implemented completely different. And we have to agree on what is the abstract concept of satisfiability, which we've talked about before, Martin. It's essentially that from all fields, you have to basically verify that from all fields, all combinations are possible to do.
Yeah, every path to every field of every type, basically, because the path, like how you get to a type, might actually affect sort of whether a field is resolvable, for instance.
Yes, and there's also things where it's not so clear with examples when it breaks. So there's cases where, especially with require and key, that you might not be able to resolve something because you're in a locally optimized place, and then you cannot, in a certain combination, get what you want. And that's probably where we have to at least try to specify it. So what I'd like to get here is a bit of input how Apollo does satisfiability, how the guild does satisfiability, and basically get an idea about how we can specify the thing. Not in a performance way. We don't care about if you use loops, Dijkstra, A*, whatever. It's more about how we can specify it. Yeah, Kamil?
Yeah, I just wanted to ask, like, because the algorithm might be quite complex to like put on the paper. So is it like, because I feel like at some point we would have to like split it into like like standalone pieces that we refer to. So like if you want to like jump from one subgraph to another, let's say, that could be like its own piece of, you know, algorithm somewhere. So because I don't think it will be like a, you know, a long list of instructions that you can actually use, because it will be like unreadable, hard to follow, you know, how to really like understand. So we would have to, I think, rethink the structure and like the, you know, all like how we describe the algorithm, I believe.
Yes, I hope that we can break it down when we forget about all of the performance stuff into a way that it's actually doable. Because it doesn't matter if you do all the checks on all the fields in all the different combination. Even if you have exponential complexity, it doesn't matter in this case. So we don't have the complexity case. You know, we only have the complexity case in let's say we have a pointer to a field. What do we need to verify for each field? And that could be just a list, and then we just have a set and go through it. So the question the question is if we can break it down to this simplicity.
I think we could like start with something and then see if it's actually like a, you know, a huge pain or just like medium pain, because it will be a pain anyway.
David?
Yeah, I kind of want to echo what Camel said, because at least I don't want to talk for Guild and Apollo, but the single most complicated piece of the composition library we have is essentially the satisfiability algorithm. And getting that in a kind of digestible kind of a way that is digestible and covers all the bases is going to be difficult. Of course, there's considerations for performance there which we don't need to consider in these algorithms, but I still think you're going to struggle to like at least in this kind of short form format to be able to put everything here in like it could be its own kind of topic essentially, is what I'm trying to say.
Yeah, we have to. I'm pretty sure we have to try, because if you, David from Wondergraph, Camille from the Guild, and Martin from Apollo, somehow together with us, be able to make it to explain it in words, we could put it in an algorithm, if it's possible to explain it in words. We'll see. If we run into something that's too complicated, then we have to see where we go there. But Benji, you're from the main working group. The execution algorithm is also simplified yet quite complicated, right? Or is it the validation algorithms? I can't remember which one.
I mean, they're all simplified but quite complicated.
Yeah, I think we can get inspired there. It's just that I don't want to not specify it or not try to specify it. I really want to give it a go and see how far we get, because as it is with most algorithmic things, the more abstract you get, the more easier it gets to specify it. So let's see.
Yeah, so I was gonna say it's the stuff that actually helped me think about those things is actually was visualizing it as your super graph as a graph structure, right? So then actually it's clear with the paths that you're taking there and how you're actually doing that. Is just I'm wondering how that actually would translate to actual spec of actually talking about but it is what we're constructing is a graph, right? When you have the types connected by the fields and whatnot, and just kind of like and for every single it's path to whatever to any leaf there, right? That's you have to be valid, but it's I think we can, as you mentioned, the GraphQL spec itself talks about the execution of the as also as part of a graph, right? So maybe that's good enough to have that simplification over there and have that, or do we need much more I guess bigger abstractions here? I don't know.
Yeah, I think some of the difficult parts are like jumping from one subgraph to another. Like we may need to find a way to describe that here in sort of generic terms. And some of those like jumps between subgraphs have requirements, interfaces, especially interface object. If we want to specify that in here as well, complicates things even further. So there's a bit of sorry?
It's not part of it yet, so we skipped the interface object for now.
Yeah, but we probably want to leave room for it in the way we describe the satisfiability checks, because it's likely to come up at some point.
If you
I think we need to go ahead, Benji.
Sorry. If you can describe it in terms of something that would be, for example, hard to write an algorithm for, but is relatively easy for a programmer to understand, that's generally sufficient. So if you say, for example, oh, this must form a graph with these constraints, and then that resulting graph must be a directed acyclic graph, for example. And I'm not saying that that's the right thing for satisfiability, but if you could say something along those lines, that would be an okay algorithm. And then it would be down to someone to actually then write the code that would do that. So abstracting over the larger concepts, so long as they are known concepts, I think is fine. finding that abstraction is more challenging.
Yeah.
I was going to say we can try writing the algorithm or try finding its place, but I think regardless, exactly what Derek is mentioning, the spec we should probably start, or at least at a minimum put in the spec text, even if we don't get an algorithm, like examples of these are schemas and where these scenarios might not be an exhaustive list, test case list of all the scenarios you might get, but this is why we need to have this step. Here's an example. We need to define some algorithm. Your validation step should define some algorithm that catches these possibilities of things like this happening, and why we need to do this. At least let's get that down, and I think that'll all help us clarify on what generic algorithm we may or may not be able to come up with for the spec text.
Yeah,
it looks to me like we've come up with quite a lot of validation rules and stuff. How likely is it that someone would accidentally build a schema that's not satisfiable? Is that quite common or not?
It's easier than you think. I've done it a few times with my examples we build.
Okay, good to know.
It gets easier the more features you use. Like if you're just doing keys and types, it's probably very unlikely. But as soon as you start doing like provides and requires and things like that, then it gets a little easier to run into those cases.
Yeah, you can. What the validation rules do not verify is if you can run into a situation where you cannot plan any further. So when you jump between subgraphs and then at some point you just cannot go anywhere, even though the schema looks fine, but the specific key combination doesn't exist that you need in this specific case for a lookup. That's how you can collide with lookups, right? The platforms have to leave. Yeah, so the discussions here, I think, is good. What we are out of time. As an action item, what would be great, I will create an issue and then I will post it to the Slack channel, also for David and Sergey, if you want to join the Slack channel. I don't know who can invite you, but someone will. Just need an email address. Then you can be part of that too. And then I will create an issue on GitHub where we can collect these things, because what we need at the moment is basically content about how satisfiability is done. I've already got Kamil's README file from his implementation where he explains his journey through through validation and examples. And the test cases that we got from you, Kamil, were super helpful. So maybe we can we also have this or for the satisfiability stuff, because that's always a good place to start. Okay.
I can help with the we can jump on a call and I can describe what I did.
Yeah, that would be great. You don't happen to have a document, Martin, which explains satisfiability in detail with an algorithm that we can just put in? Okay.
I don't think so. Like Derek might know more about the current state of documentation, but I don't think we have anything that's necessarily helpful.
Not really. It's ultra the code.
Oh yeah, that's the best documentation.
Well, code doesn't lie, right? So that's
okay. So I will ping you, Kamil, on Slack, and then we can make a meeting, and everyone which wants can join. So it's it would be outside of the structure, and then we can see. We have to try to specify it somehow. If it's not in algorithmic form, then ideal cases we find a super simple algorithm to do it, which is not too simple, but we'll see.
One thing I think you should keep in mind when you're discussing this is that the result of this needs to be actionable. So just, for example, just throwing up your hands and saying, this isn't totally satisfiable is not ideal. really you want to be able to point to the parts of it that aren't satisfiable and explain why as part of this algorithm, because people need to be able to fix it. So if it comes down to being because you've added external to this particular position and that meshes badly with this other directive on another place, then you want to surface those details. And I think if you can come up with the scenarios where things are not satisfiable and then see if you can fix those with validation rules rather than doing it as a final satisfiability check, that would also be helpful here, because then you're only looking at a small subset of things rather than the entire graph. But yeah, I understand that there are complexities depending on how you traverse the graph as to what information you had available during traversal.
Yeah.
Awesome. Okay, thank you, everyone. I'll see some of you in 25 minutes. Otherwise, catch you next month. Thanks, everyone. Bye.
Right.